like I said, today we are talking about scientific notation, which scientific notation definition for that is a method of writing very large numbers or very small numbers using a power of 10. Okay? And let's take a look at our examples here. It says when we're writing numbers in standard notation, we're going to take our scientific notation, this number right here, this 1.35 times 10 to the 5th power, that's scientific notation. Okay, when it says we want to write in standard notation, that means like write it like a regular number. Remember, you guys should be copying these down in your notes. Anything that's up here should be the exact same as in your notes. Now, if we were actually to figure out 10 to the 5th power, if we actually did 10 times 10 times 10 times 10 times 10, we would get 100,000. Now, hopefully you guys remember that. Oh, yeah, I know. Whenever I have 10 to a power, it just means how many zeros I have on that number. Like 10 to the 5th power, well, I write 1 with 5 zeros. Okay? Hopefully you guys remember that. You do now. So if you were to actually figure that out, 1.35 times 100,000, you would get 135,000. But there's an easier way to do that. All we really have to do is move our decimal. Yep, on this one, move the decimal to the right 5 places because 5 is my exponent. Okay? So when we're moving our decimal, all we have to do is grab our decimal, move it to the right 5 places, and then fill in those empty places with zeros, and that will give me my answer. Now, down here at the bottom, on your helpful hint, it says a positive exponent means you're going to move the decimal to the right. Okay, this is important. Positive, you're going to go to the right. If we have a negative exponent, which we will be dealing with negative exponents today, you have to move the decimal to the left. Now, the process is the same. The only difference is we're moving our decimals in different directions. Okay, but that's the only difference. Well, point would be yes. Yeah, we could have, if you have a negative, the answer itself isn't going to be negative. In fact, it's going to even be larger than 0, but it'll be very, 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 very small. Okay, whereas if you have an exponent, a positive exponent, your number is going to be very, very, very large. Okay. Yes, they will all be positive. And let's take a look at our next example here, and it's showing you exactly what we're talking about here. Okay, our second example here says 7 times 10 to the negative 3rd power. Well, if we were going to try to figure out 10 to the negative 3rd power, we could figure that out by, if you remember, doing 1/10 and then multiplying 1/10 times 1/10 times 1/10, which would give you 1 over 1,000. Okay, and then if you were to actually multiply 2.7 times 1 over 1,000, well, we know that we get 2.7 over 1,000, and then that division bar means, or that fraction bar right there means divide by. That's how come they ended up with 2.7 divided by 1,000. So we'd end up with this small number down here, this 0.0027. Now, the easiest way to do that is just like what we talked about on our helpful hint a moment ago, is to think we have to move the decimal to the left 3 places because it's negative 3. Okay, and that's simple enough. I mean, you guys could take your 2.7 right here and move your decimal 3 places to the left. 1, 2, 3. I mean, that's it. That's all there is to it. Okay, there's no real. I don't want to say there's no math involved in it, but there's no actual multiplying or dividing that we have to do. Okay. Questions on that? Yes, sir? Yep. Move your decimal, whatever the power is, whatever your exponent is, that's how many times you have to move your decimal. And that's it. Yes, sir? No. Has to be 10. But that's a good question, though. He asked, can it be on any number? What if the number right here, instead of 10, what if it's 5? Well, if it's 5, it actually wouldn't be scientific notation because all of your scientific notation is going to be written just like this right here. It's going to be written a number, okay, with one number in front of the decimal, okay? If you have more than one number out here, like let's say we had 27 times 10 to the negative second power, that wouldn't be scientific notation because it has two numbers in front of the decimal. We'd only have one number in front of the decimal, which is, we have our 2, 0.7, and it's always going to be times 10 to a power. That's what makes it scientific notation. Okay, if it was times 5 to a power or some other number, it wouldn't be scientific notation. Okay, let's take a look at our next example. All right, this one, it asks us to write this in standard notation. So we have 2.01 times 10 to the 4th power. Now, the first thing we need to do is look and see, well, is our exponent positive or negative? Yeah, on this one, our exponent is positive because we have a positive 4. Okay? Now, since it's positive, what direction am I going to move my decimal? Am I going to move it to the right or left? Yeah, I have to move it to the right. So I'm going to have my 2.01, and I have to move my decimal 4 places to the right. Okay, so I'm going to go 1, 2, 3, 4. I'm going to fill zeros in there for those guys. So what do I end up with? 20,100. And that's our answer. Nothing else we have to do. Okay? I don't think so. We still have to do a negative one. Now, and another way to help you remember this is, remember, if it's a negative exponent, your answer is going to be really, really, really small, meaning a number behind a decimal. And if it's positive, it's going to be really, really, really big, which means that it's going to be, well, in this case, no decimal. Let's take a look at our next example. All right, this one we do have our negative exponent on this one. Okay, so since it's negative exponent, which direction do I have to move my decimal on this one? Yeah, I have to move it to the left. Okay, so I'll write my 1.9 down here, and I will move my decimal 5 places to the left. 1, 2, 3, 4, 5. Put my decimal right there, and then fill in zeros for those guys. So I end up with 0.000019. I don't know, is it tenths, hundredths, thousandths, 10 thousandths, 100 thousandths? Yeah, millionths. So I would say that'd be 19 millionths. Or 0.000019. I like that one a little better, but that's just okay. Questions on how we get that? Questions on how we've done that so far? No? All right, then let's talk about how to write a number from scientific notation to a regular number, to standard form. Okay? So let's take a look at this. It says a number less than 1 will have a negative exponent. Okay, when written in scientific notation. And then remember, we just talked kind of about that because we have a negative, anytime we have a negative exponent, our number's going to be really, really, really small. It's going to be bigger than 0, but it's going to be smaller than 1. Okay, so what we have to do is whenever we're writing a number in scientific notation, we need to think that there can only be one number in front of the decimal. And on this one, if we look at it, what number, because this is really the number we're going to be looking at right here, the 709. Okay, and we're going to have to move our decimal over to where there's only one number in front of it. Well, what number is going to be in front of the decimal? Yeah, it has to be 7, right? Because, well, if we moved over any further than that, then we'd have 2 numbers in front of it. It would be 7D. Well, we can't have that, and a 0 doesn't count, so we have to move it all the way over to where it's behind the 7. So we're going to end up with 7.09. Well, how many times do we move our decimal to get it over there? 1, 2, 3 places. Okay? So, since we moved that over 3 places, that's going to be our exponent. Yeah, and since we moved it, since the number was smaller than 1, our exponent has to be negative. So that's how we get 7.09 times 10 to the negative 3rd power. Remember, your scientific notation is always going to be in this form right here. You're always going to have some number times 10 to a power. If you don't have some number times 10 to a power, it's not scientific notation. Yes, ma'am? That's correct. Well, what number is going to be in front of the decimal? That's right, the 3. So you're still going to have the 3.007 because you can't get rid of all that other stuff. Okay? But that's going to be the number that's going to be in front of your decimal. All right, let's take a look at our next one. All right, this one right here. says 0.000811. Write that in scientific notation. Well, how are we going to write that in scientific notation? Well, I can tell you right now, what do we have to have for it to be scientific notation? We have to have some number in front of the decimal, and then what? Yes, ma'am? Yes, and what else? I'm looking for something. Yes, sir? Well, yes, but what else? Okay, what I'm looking for is it's going to be some number times what? 10 to something power, right? So we know that we're going to have some number times 10 to the something power. We know that already. Okay? Now, well, let's take a look. Where is my decimal going to be at in this question whenever I move it? Where does it have to stop in between? Yeah, right. I have to move it to right here. So I'm going to count 1, 2, 3, 4. So since I moved that 4 places, I know that my exponent is going to have to be -4. And I know that my number up here is going to have to be 8.11. So my answer for that would be 8.11 times 10 to the -4th power. And that's it. Not that hard, right? No? All right, let's take a look. We might have our next example. We have one. Oh, no, that's it. Now, but let me ask you this. What happens if this number was, let's say it looked like this. Well, where's my decimal going to go on this one? In between the 8 and the 1 again, right? Yeah, the only difference is I have to move it over 1, 2, 3, 4 times. So instead of this right here, it's going to be 8.11 times 10 to the +4 power. Okay, so be careful on that. But the process is the same, and I think that you guys can do well on that. All right, any questions on that? No, well, that's not a question on this. Yes, sir. Yes? Mm-hmm. Yes, because the number is larger than 1. Remember, if the number is larger than 1, you're going to have a positive exponent. If the number is smaller than 1, it's going to be a negative exponent. Okay? All right, any other questions on that? Yes, sir? No, standard notation means like write it in like a regular number. Yes.